All right, welcome back, students. In this video, we're going to cover the second half of Module 11 Study Guide. I'm not going to say this is the last video because I think I'm going to do a couple of, I'm going to try to do a video on the EOC reference sheet, the calculator, and probably at least the station I'm going to do during boot camp. So yeah, we'll say more to come. But for tonight, I'm going to finish this half of the study guide. Sorry it took me. I had to have my stuff ready by today for the boot camp, so I had to do some work on that. So, number 9. This is on the page 5 of 8. So, what is the surface area of a sphere with the radius of 9 centimeters? All right, so surface area, sphere. Yeah, sorry, I just printed this. I lost the other half of the sheet I was working on since this, and it's not laying flat, so it's being weird. All right, so check out the reference sheet. You'll see that surface area for a sphere is 4 pi r squared, 4 pi times the radius squared. All right, a radius here is 9. So, all right, so 9 squared is 81. And 81 times 4 gives you 324 pi. So in your calculator, you would be up, as you're multiplying here, you're 9 and you square it. And then 4 times 4 gets you here, then times pi equals, and it's going to get you the surface area. Excuse me, as far as the calculator goes. So if we're going to do this on the calculator, now I'll always like to start with the number that has to be squared. So you would type 9 and then the x squared button, excuse me. So, all right, so this guy. So if you're going to square something, it's this. If you're going to take the square root, it's this. This button over here, if we're going to do anything besides square. So if we're going to go, this is basically saying whatever number, this button says, all right, we're going to use an exponent, x being the exponent. The next number I type is that. So if we were saying, say like 3 cubed, you would go 3, this button. So it's saying we're going to exponent. That exponent is to the third power, which is cubed, and that's 27. 3 times 3 is 9, times 3 is 27. So just a quick calculator lesson. So sorry. Oh, we'll keep it over here. So we're going to go 9 squared. So there's our 81. I think I said it, but I didn't actually write it on there. Times 4. So there's your 324. So we went 9 squared. How did I do it? Did I go 9 squared? And then, no, if you just hit 4. Okay, so you have to hit times. So times 4 equals. So 9 squared times 4 equals. And then it's times pi. Pi is this button. And remember, on the test, unless it says pi equals something specific, like 3.14, this is pi. So any of our problems on that test, that is pi. So the times pi. Now this is pi. We have to hit equals again. But so 3.141592654. It goes on and on. If you'd like to see the number further out than that, come to my room and I'll show you. And then we hit equals. So we got equals. And it gives us 1017. Sorry, I'm not going to. So it's 1017.8. And these are square centimeters, because we're talking about surface area. And so the closest we can get to that is if we round up. Sorry, this is a terrible 8. We round that up and we get this guy. All right, number 10. So a right meaning it's, right angle. Regular hexagonal prism. So regular means all the sides, all the angles, all the edges, all that stuff are congruent. And hexagonal, so it has 6 sides. All right, so it has blank planes of symmetry that are parallel to the base. So the base is here, parallel would be to the ground. So we cut it here, and symmetry means, we can cut it and it can map onto itself. So we cut it here one time. All right, then it says blank planes of symmetry perpendicular. Well, here's your clue. So that's perpendicular, right? Well, so is this guy. So is this guy. So is this guy. So is this guy. And so is this guy. So 1, 2, 3, 4, 5, 6. Just like it has 6 sides. So it goes 1, 2, 3, 4, 5, and 6. All right, flipping over, page 6, number 11. So this thing kind of stretches to the next page because it's so big, but it's axis symmetry. So, how can we cut it? Let's see. It's this way. Hold on. On its axis, which is weird with the sphere, but that's a yes. This guy, that'd be a yes. This guy, that would be a yes. Now things get dicey. Things get dicey at the bottom of the page. First off, this one's down here, so E, it's no, but it's on the next page. I'll show you why. So this, you look at this, this looks like a cube, right? Well, according to McGraw-Hill, they says no. They say it's rectangle, or I don't know, for whatever reason they say it's not. I don't know. I'm yet to get a complete explanation. We're going to flip over to page 7. I'm going to tell you, so 14 was cut out of cut off the test. It's a little bit more difficult of a problem. I will be glad to work it for you if you come by. I have tutoring tomorrow afternoon, and then also I'm going to try to tutor at least every Wednesday, next Wednesday, and I'll try to squeeze in one other day if I can. I'll send out a message. Anyway, so let's go flipping over page 12. I'm sorry, not page 12. Number 12, page 7. All right, so, and this went with number E, which was no. And I'm not sure. It looks like, I don't know. That's what they tell us. But so number 12. A certain airline requests carry-on luggage be designed to fit in a rectangular prism. So, you guys know I can't draw, but we're going to try anyway. Happy little accidents. Oh, well, that's best. Well, yeah, I don't know. I screwed that up. But anyway. So rectangular prism, its length, so how long it is, let's see. Actually, let's draw some dotted lines. It may make it look better. So its height, so height is 12, width is 8, so length, that'd be here. It's going to look weird, but the length is this, and it'll be 8. No. Well, either way, 24, excuse me. Something's wrong with the numbers. It's my drawing, but anyway. So the volume of a prism is your base area times height. Well, because this is a rectangular prism, the base for a rectangle is length times width. So you can convert this to this because it's the same. So all you're really doing is multiplying these three numbers, which is 24 times, 24, 12, and 8. This looks like a 10 because I apparently can't write. 24 times 12 times 8. So 24, 12, 8, 2304. 2304. Now I can tell you the airlines are not going to ask you about volume of your luggage. They're going to ask you pounds. And if you're more than 50 pounds, you better hope you have another luggage or some carry-on. Otherwise, you're going to have to throw away some souvenirs. So don't buy too many souvenirs when you go out of town. Just my piece of advice for tonight. Okay, number 13. All right, so we got some conical paper cups. So I mean, it's a cup, but it's shaped like a cone. And they tell you that they have a height. So height is 2 3/4 is the same as 2.75. So I'm going to box that in. And the diameter of 1 5/6. So watch this. We're going to go 1. Oh goodness, Sariana keeps trying to teach me how to use this calculator with the fractions, but that's okay. We're just going to go, so 1 5/6, you know that 6 over 6 is 1, and then, so 6 over 6 plus 5 over 6 is 11 over 6. So that's your diameter. Diameter is 11, so we'll just say 1 5/6. So the radius is half of that, so divide it by 2. So then we're going to round, so it's going to be 0.92. All right, so radius is important. All right, so now we're looking for, if we're filling the cup, should be volume, but I just wanted to find it somewhere. Yeah, there it goes. Volume. So, all right, so a volume for a cone on our reference sheet is 1/3 of the base area times the height. Remember, the base is a circle. So we're going to replace that. And instead of writing a third, you can multiply by a third, or we can divide the whole thing by 3. I'm just going to write it this way. So there's where our fraction is. V equals pi r squared, because that's the base area, and the height divided by 3. So over here, let's plug that in. So pi, our radius is 0.92, and we're going to square it. And then our height is 2.75. Hopefully you can read that. So on the dang it. Oh, I should have left that on there. So here's our diameter, here's our radius. We're going to square it because it's radius squared times 2.75. That's the height, equals times pi equals, and then remember we had to divide it by 3. All right, so 2.41, I think they wanted, nearest 1/10 of a cubic inch, so it'll be 2.4 cubic inches. So hopefully I didn't lose you there. So this was the volume. We had to half the diameter, and then it's just pi times the radius squared times the height, and it's divided by 3 because that's the. So, all right, 14 we're skipping. Flipping over page 8. This is it. Thank goodness. I promise I'll be back with more, but it's good to at least get caught up for the moment. And it's also good because I'm pretty sure. Yeah. So. Yeah, I can correct this because I told some folks wrong in class, so you guys that are getting this will hopefully get this question right. We're going to use the scale factor here and here, density, for these bottom two. Now here, because it's volume, we found out, so this is separate. You don't have to write this, but scale factor. And this goes, hopefully you guys are listening. So scale factor for like area would be A to B. So new over old. This is new. This is old because it says first that's old, this is new. If it's surface area, it's A squared, B squared. And then if it's volume, it's A cubed, B cubed. See, that'll come in handy here. But here, so we're going to, I think I had said to just take the scale factor, multiply it by the area. They give you the area for this guy. And if you do that, you're going to get, I think, this, and that, I don't believe that's correct. Well, so we're going to see. First, we're going to take, because the area, base area of a triangle is 1/2 of the base times the height. So we have the 12.4 over there, and we have this, we have the base, which is 6, and we're looking for the height. Now I want to get rid of this fraction, so I'm going to multiply both sides by 2. So it's going to cancel out here. 2 times 12.4 is going to be 24.8, and it's going to equal 6h, 6 times the height. So divide by 6, divide by 6. So just to make sure, 12.4 times 2, 24.8, divided by 6. All right, so this other side's 4.13. So now we can, so take the scale factor, 10 over 6, new over old, multiply it by this side. So 4.13. So 10 divided by 6. Let me just make sure again. Sorry. Yeah, I did something wrong. Okay. Times 4. Let's do it again. My goodness. All right, so it says this other side is going to be 6.88. Multiply these together, and you're going to get 68.8. Remember, it's 1/2 though. Area of a triangle is 1/2 base times height, so we're going to take half of that. So 68.8 divided by 2 gives you 34.4. Yeah, and that's kind of what happened. The number was bigger and everybody was getting it wrong, and I had to look, and yeah, that was what was happening. So I apologize. I've never told you guys I'm perfect, so now you know. If you didn't, hopefully you never thought that. All right, cylinder. So cylinder has a volume, and it gives you that, and here's the height. It's saying the volume of a similar cylinder has a height of 12. So what is the volume of the cylinder? Similar cylinder. So volume for a cylinder is base area times height. Just going to double check. Yeah, making sure I don't go at anything crazy. Actually, this one we don't really need that. We'll leave it there. But so our scale factor. So new over old. So your new over old. So 12 over 8. Now it's volume. Volume is a squared b squared. So we're going to, cubed. So we're going to cube these two. But before we do, I happen to know that 4 goes into both of these guys. 4 goes into 12. Say 4 goes into 12 3 times. 4 goes into 8 2 times. Now we can cube these. Also, of course, again, if you want to do it here, it's 3, this button. And because we're cubing, it's 3 again. That'll give you 27. And then 2 cubed is 8, but I'll just show you. All right, so we're going to divide those two. And then we're going to multiply those by this volume to get the new volume. So that times 132 gives you 445.5. So what we did is we took old volume and then we multiplied it by new over old cubed, and that gave us new volume. Hopefully that makes sense. All right, 2 more. Almost done. Almost done. And it's getting late. It's been a late night every night this week, but we're almost done. Okay, 17 and 18. So 17, density, easy stuff. So 2 types of density. I'm going to go ahead and write both formulas. These are not on the reference sheet. So 17 is going to be dealing with area density. And that is your number over your area. And that could be people. In this case, it's going to be bison. So bison over square miles. So it's between this and this because it's between this and this. So over here is 2,400 divided by 3,472. And for this guy, it's going to be 5,400 divided by 3,472. You got some options at the bottom. They're both pretty close. So 2,400 divided by 2,400 divided by, yeah, see, it was still in there. Dang it. 2,400 divided by 3,472 gives you 0.69. Is that an option? Survey says yay. All right, other side, 5,400 divided by 3,472 equals 1.5556 because you see 5 and then another 5 makes it the 5 6. At least it wasn't 6 7, right? Right. All right, 18. So density this time, because we're dealing with rebar, they're wanting to know it has to deal with weight over volume. So for ours, it's going to be density equals, we already have the weight, 108.8, because it tells us over here. So let me read the problem. Reinforcing bar, also known as rebar. It's a cylindrical steel bar used in reinforced concrete construction. A 9-foot piece of rebar has a diameter of 2.25 inches. So we got feet and inches. Just pay attention to that. But it weighs 1.8 pounds. What's the density of steel? Pounds per cubic inch. So inches, we got a problem here. To the nearest thousandth. Now remember, just for so this is 3 spaces. That's tenths, hundredths. I ain't gonna write it all, and then thousandths. So that's 3 spots. Now, so we have this. We need volume. Volume for a cylinder is the base area times the height. Base area of a cylinder, that's a circle, so it's pi r squared times the height. All right, so diameter, 2.25. The radius is half of that, so your radius, radius is 1.125, and we're going to square it, and we have pi. So we have one problem, though. So our height is 9 feet, but everything else is in inches, and we need our answer in inches. So 1 foot equals 12 inches. Now, just in case you guys forget that, if you go to the reference sheet, so we got 1 foot equals 12 inches, a yard's 3 feet. You got a few of these. Down here, distance formula, midpoint, slope, special right triangles, you're going to love those. And on the back's all of our, so where's it? Cylinder, see, base area times height. Of course, this is a circle. If I look to a circle, for the area, it's pi r squared. So that's how we know to do that. So, just showing that I'm not making this sort of stuff up. All right, so if we have 9 feet and 12 inches, or 1 foot equals 12 inches, we have 9 feet times 12 inches. 9 times 12 should be 108. So our height is 108 inches. So 108. All right, so 2.25 divided by 2, that's our radius, and we're going to square it. Then we're going to multiply it by 108. We're going to hit equals. We're going to multiply it by pi. We're going to hit equals, and all this, so the volume of this guy is 429.42. We're going to round that up. So 429.442. So now the density is the weight. That was 108.8 pounds, and we're going to divide it by that volume, 429.42. You see it gives us 0.2533. So tenths, hundredths, thousandths. this is not bigger than 5, so the answer is 0.253 pounds per cubic inch. All right, this concludes lesson 11. This also concludes the McGraw-Hill Florida Best Geometry for 2025-2026. Congratulations, we made it. Like I said, we'll do some review. Test is in less than 2 weeks. So let's lock in. Let's do what we can. Come see me. I can stay after till 3 p.m. if you got a ride just about every day. And if you guys are staying and want to learn, I will teach you. So let me know. Send me a message. If you have one of my colleagues, let them, if you can't get a hold of me, then tell them, say, hey, can you let Mr. Whitlock know I'd like to stay for tutoring. So I am staying tomorrow, Friday the 24th. So hope to see you. Until next time, have a good night.